That's crazy. Let's think of them as bunches. So it's just like when you go to the store, you don't buy one grape, you buy a bunch of grapes. You don't buy one egg, you buy a dozen eggs. Maybe a half a dozen, but usually a dozen. Anyways, you buy them in groups. So he goes, let's talk about atoms in groups of 6.022 times 10 to the 23. And we'll call this a mole. So just like 12 equals a dozen, 6.022 times 10 to the 23rd equals a mole. And this makes it so much easier. Look at this. So now we can say, instead of one atom of carbon weighing 1.99 times 10 to the negative 26 kilograms, we can say 1 mole of carbon weighs 12 grams. 1 mole of oxygen weighs 16 grams. 1 mole of helium weighs 4 grams. 1 mole of beryllium, right? So you just look at the periodic table, you find the atomic mass, and that turns to grams. And it's so much easier to work with. All right. Let's do some conversions here. I want to know how many moles are in 17 grams of carbon. That's fine. 17 grams times in a line. That's how we do conversions. We want to get 2 moles, get rid of grams. So mole goes on top, grams goes on bottom. We need a conversion. You look at your periodic table, you'll see that 1 mole of carbon equals 12.01 grams of carbon. You do your math, you get 1.415. You only get 2 sig figs, so it turns to 1.4. So, I want you to spend a minute or two on your own, seeing if you can't figure out how many grams are in 1.3 moles of calcium. I'm going to give you a minute, and then I'm going to come back and do it for you and see where you're at. Smart board mode engaged. Alright, 1.3 moles times in a line. What am I trying to get to? Grams. So grams goes on top, moles goes on the bottom. I look at my periodic table, I look for the conversion. What's my conversion?
12.01 grams. What?
How about 40.08?
Oh, it's different to...
Every atom has a different mass, yes. So what does it come out to be before you round?
52.104.
Wait, how do you do this again?
And you only get 2 sig figs. So your answer is 52 grams. Now you're going to try another one. There you go.
25. What? How are they all wrong?
Okay, A is actually correct, by the way. I just didn't mark any of them as correct. But let's go over and do it. All right. Smart board.
So that was messed up.
Activate. All right. So, what did I ask?
You asked 23 grams of energy is equal to how many moles of energy?
So 23 grams times in a line. What are we trying to get to?
Moles goes on top and grams.
So moles goes on top, grams goes on bottom. What's our conversion?
1 over 24.2451.
Okay. So it comes out to be 0.9463, but you only get 2 sig figs, so you got to round this guy, right? And since the 6 is next to it, it rounds up. So the answer is 0.95.
I'm doing something wrong.
Here's the next one.
I don't even know the answer. I'll put in 5. Was that right?
Yeah!
Yeah!
Yeah! Yeah! All right. Smart board mode engaged. Here we go. So it says 1.25 moles of boron times in a line. 1 mole equals what? Say 10.81.
You put 2 ones.
There's 2. Your periodic table might not know as much information as my brain.
Okay, there's 2.
It says 2 on the
On some of them it does, yeah. Some it will, some it won't. Okay, I'm smarter than your periodic table. What do you want me to tell you? It doesn't matter. So, you do this, what do you get for an answer? 13.545.
I didn't put a decimal on
You get 3 sig figs. 13.5.
Yeah, I had the right answer.
Yeah.
So everybody hit 13.5 and send. Okay, last thing. Alright, molar mass. Basically just how much does a mole weigh, right? The mass of a mole. So, think of hydrogen and oxygen making water, right? 2 hydrogen atoms come together with 1 oxygen atom and they create 1 molecule of water. Well, that atom stuff is confusing, remember? So instead we like to talk about moles. So what you can say is 2 moles of hydrogen and 1 mole of oxygen came together and made 1 mole of water. And it's a lot easier to work with. Okay.
Maybe we should know Italian.
So, here we are. If we want to calculate how much anything weighs, we can just look at the periodic table, right? You want to know how much carbon weighs? You look at the periodic table, oh, look at waste 12. Water isn't on the periodic table. So when you need to figure out how much it weighs, you just add up all the stuff that's in it that is on the periodic table. So water weighs about 18 because you add up 2 hydrogens that are about 1 apiece and 1 oxygen that's about 16. 2 plus 16 is 18. Okay? So it's just, the problems are exactly the same as the other ones. You just have to add something up first to figure out your conversion factor. So how many moles are there in 25 grams of water? Let's check it out. 25 grams times in a line. You're trying to get to moles, so 1 mole goes on top, grams goes on bottom. You add up your 2 hydrogens, your 1 oxygen, you get 18. Do the math, 1.388. 2 sig figs, 1.4. So here goes, try some. Oh, that went terrible, you guys. Okay, yeah, because we don't have time for you to sit around and not know what you're doing. So, what you should have done is you should have added together the mass of 1 silicon and 2 oxygens. We got this time. We got 1 more question, guys. You should have come up to around 60. So if you were around 60, you were correct. All right, last one. Here you go.
You're going to practice tonight? And you try to find...
Hurry up, people!
Okay.
All right, guys, I'm going to do it.
Yeah. That was
Okay, we got time. Just calm down. Smart board mode here. All right, so 22 grams of carbon dioxide times in a line. 1 mole of carbon dioxide should weigh about 44 grams. Because you add up because you add up the weight of 1 carbon and 2 oxygens, you get about 44. 22 divided by 44 is 0.5. But you have 2 sig figs, so it has to be 0.50.
I'm doing something wrong. I did it. Disgusting.
It's like a whole handful. It's like the size of my fist.